Moshe, hello,
Ji, sir.
yes, are you done with this drawing?
না স্যার মাত্র আসলাম আমি শুরু করতেছি স্যার মানে হাফ করছি
So what you wrote for the first one?
ওই যে স্যার আগেরটা ওটা ছিল when the magnet is taken towards the coil then due to induced EMF current a south pole is produced closer to magnet তারপর কই গেল
So you tell me slowly so that I can write.
আচ্ছা স্যার
When the
magnet is taken towards the coil.
So here it will be away, right?
Oh, achha, yes, sir.
Away from the coil, right?
Yes, sir, coil.
Then
due to induced EMF
current in bracket current, then
a south pole is produced.
Here it will be north pole, right?
Yes, sir.
North pole will be produced
closer to magnet.
Huh?
Yes, sir. For a bracket according to
right hand grip
rule. Yes, sir. Bracket close.
Grip rule. Then what is then after that?
Which does not allow the magnet.
Which does not allow the magnet
to go more forward. Go
further apart. Here we write further apart.
Yes, okay? Further apart. Yes, sir.
Further apart. Okay, it is done, huh? Okay, this sir. Diagram you draw and write this statement beside, huh? Okay, thank you, Moshe.
Welcome, sir.
Sir, should we produce closer to the magnet?
Yes, because the magnet is now taken away, right? So if you are taking away the magnet, you will get opposite induced EMF. Okay. Previously you got the direction of the EMF. Yeah, direction of the EMF. Now you are getting the opposite direction of the EMF. You see, right hand grip rule, the arrows were that time upwards, right? Now it is downwards, isn't it? For the current, previously the arrows were upwards. Can you remember in your drawing? You have is also it drawing before, isn't it? Aisha, should I show you?
Yes, sir. Yes, sir.
I am showing you then, no problem.
No, I know.
Yeah.
স্যার পরের বার ইউজ করলে ব্ল্যাক ইঙ্ক ইউজ করেন স্যার, ব্লুটা স্যার চোখের মধ্যে স্যার ব্যথা হয়ে যায়, দেখতে অনেক কষ্ট হয়।
Black. I should use black
ইয়েস স্যার, তাহলে
or
হোয়াইটের
any
মধ্যে
other
ব্ল্যাকটা
color
একটু ডার্ক হয়ে দেখায়।
or red color. Which one?
স্যার রেড হইতে পারে, ব্ল্যাক হইতে পারে, ইচ্ছা একটু ডিপ হইলেই হয়। এই ব্লুটা স্যার দেখা যায় না স্যার।
Okay, I'll try. No problem.
অথবা এমন একটা কালার দিয়ে মানে যেটা ডাল না, ব্রাইট, যেমন এখানে পিঙ্কও আছে, অনেক ব্রাইট, যেটা চোখে লাগে।
Okay, I'll do that. Inshallah. Now, I'm trying to change. Why it's not getting changed? This from the top, right? Format from that part.
ফরম্যাটে চাপ দেন, এই যে পিঙ্ক।
But here is still showing blue. I pressed it. Okay, I'll check now. Let's see. It's coming. Still, it's coming like that.
কই, আমার তো এই যে পিঙ্কই আসছে।
Maybe there is some setting problems. I have to check.
না,
I'll check it.
পিঙ্কও বোঝা যায় না। পিঙ্ক না, ইয়ে রাখি, ব্ল্যাক দিয়ে দেখি।
ব্ল্যাকটা বেটার
So,
অনেক।
হ্যাঁ,
so are
ব্ল্যাকটাই
you
বেটার,
done with
এক্স্যাক্টলি।
writing and drawing this part? This diagram.
হ্যাঁ স্যার, লেখাও শেষ, ড্র করাও
হ্যাঁ,
শেষ।
তবে ব্ল্যাক যদি আবার লিখার উপর দিয়ে যায় তাহলে আবার, আচ্ছা লিখে দেখি।
না, ব্লু না লিখার উপর দেখামরি খুব একটা চমৎকার দেখা যায় না ভাই, বলে লাভ নাই।
সেটাই না, ব্ল্যাকটা তো বোঝা যায় না, ব্ল্যাকটা। হ্যাঁ,
রেড ইউজ করলেই তো হয়।
Okay.
আমি অনেকগুলো কালার ইউজ করতে পারি।
So if you are done with this one, we will go for the third diagram. Huh? This one, 23.5. This one you draw. Huh? And here you
আচ্ছা
see,
স্যার, ফার্স্টেরটা আগে, থার্ডটা সেকেন্ড এবং সেকেন্ডটা লাস্টে কেন স্যার?
because we can compare. Huh? If they are side by side, we can compare and concentrate the difference easily. That's why.
হ্যাঁ, ব্ল্যাক কালার।
Right, Moshi? If you have
Yes sir.
both of them
Sir, I can
together
see.
beside, then you can compare and you can get the difference easily. Now the third one, this one you draw, then I'm writing the statement about this one.
এঁকেছি।
Okay, very good. So this one, now I'm writing the statement for this one. If the magnet is not moving, there is no induced EMF or current, since there is no change in magnetic flux or magnetic field lines are not cut by the coil. Okay, so this one you can write either of the ways. You can write there is no change in magnetic flux or magnetic field lines are not cut by the coil. If you are done with drawing and writing, then let me know. We'll go to the next content.
Done, sir.
I think join both done.
And you see here the pointer is at center 0. That means it does not have any deflection. There is no induced EMF or induced current. So all of you are done. What about Azmine? Azmine. Hello, Azmine. Azmine is silent. Yakin, are you done?
Yes, sir.
Okay. Okay, all of you are done, right?
Yeah.
Then we can go to the next one.
Yes, sir.
Okay, look, here we have described a simple form of AC generator, rotating coil or rotating magnet, and the use of slip rings where needed. Now, in our syllabus or in our book, we have the rotating coil one, okay, not the rotating magnet one. If you understand rotating coil, you can also understand rotating magnet. That means AC generator we can get in two ways. Either we can rotate the coil, then magnet is fixed position, and or we can get rotating magnet. If the magnet is moving, then coil in fixed position. Just now we did, right? Where coil is in fixed position, then magnet is moving. And previously at the beginning of this topic, I gave you that where or the conductor is moving, but the magnet is in stationary position. Can you remember at the beginning you got the notes? Hello?
Yes, sir.
So you relate, whatever you are getting now, you relate with the previous one. Then your understanding will be more stronger. Okay, you can link with one another. Now, please write the heading AC generator. Are you seeing any diagram?
চোখ ফুলে গেছে।
এটা ড্র করতে বললেন না স্যার প্লিজ।
You have to. This is the last.
Hi.
Hey, listen, this is the last diagram in this O level. You have to draw.
শুনছিলাম শেষ ভালো যা সব ভালো, তা লাস্টেরটাই তো সবচেয়ে জঘন্য মার্কেট ড্রয়িং স্যার।
All soil that is.
এতদিন ভাই ট্রলি একটা
and listen, I am very kind on you. Hey, Adnan, your network.
আদনান তোর ওয়াইফাই খারাপ, এই কথা কম বল।
Adnan, your sound is not coming clearly. Look, I am very
এখন
kind on you. Yeah. I will not
Sir,
say you
যেমন
to draw both the diagrams. I will just explain from the single diagram. Okay. So I can do this thing for you only. Okay. But you
Sir,
have to
which
draw
diagram
কোনটা
should we
কোনটা
draw?
আঁকবো স্যার?
The
the
first
upper
one,
one.
like second one.
The
এই তো
upper
স্যার
one.
বই বুঝে একদম
Okay.
ভালো বাসটাই দিলেন স্যার, কঠিনটাই দিয়েছেন স্যার, নিচেরটা তো তাও ইজি ছিল।
Listen,
নিচেরটাও
না
same.
সেম সেম
listen. I could tell you to draw both. I made your, labor or your all the efforts half, right? Here, you can give half effort to finish it. No problem.
স্যার কত বাজে ক্লাস শেষ?
10:25. We have more 22 minutes.
আল্লাহ,
Please draw, huh? Adnan, you will enjoy it, inshallah. You finish drawing, you will enjoy it.
এরকম ডায়াগ্রাম না আগে একটা আঁকছিলাম ডিসি মোটরের জন্য।
That one you drew for DC motor, and there we use.
হ্যাঁ ওই তো ডিসি মোটরের
Yeah,
জন্য।
yeah. Remember, there we used split
Splitting.
ring,
Yes, sir.
split ring commutator. But here we are using slip rings. Okay, slip rings we are using to get alternating current. If you are done with this, then you are done with the great things. Okay, it is the toughest thing in electricity and magnetism. The other things are very easy.
ইজি।
Sir,
Yes, please. Yes, please.
magnetic field lines move from north to south, right?
Yes, yes, yes. So it will be now, your field direction is right side. Okay.
Yes,
You
sir.
should use the right hand grip rule here. Fleming's right hand rule. And that time your direction of first finger should be right.
Yes, sir. I got it now.
Yeah. Once you are done with drawing, let me know. Then I will explain. Huh? Because
Sir, your caption কি দেব?
caption you write AC generator. Huh? AC generator.
আকাশ শেষ।
Okay. Very good. So should I start the discussion, everyone? Are you ready? And
Sir, 2 minutes.
if you are done with drawing, you ready with your right hand, huh? To use the Fleming's right hand rule for generator. And Irakin asked me one question. According to that question, I'm showing you. Okay, it's coming. Red color. Now it's working. Now it's clear, right, Moshe?
স্যার
Yes, লিখার টাইমে ইউজ করলে আরো বেশি খুশি
Yes,
হইতাম
it will come also for writing now, inshallah. All will come red. So it is our direction of magnetic field lines. you fix your right hand and you show the first finger towards right, and also maintain that current should be perpendicular and thumb should be also perpendicular. Okay. Now
And
we are
index
getting
finger towards the screen.
index finger not towards the screen. Index finger will be right side.
Okay.
That is field direction, magnetic field direction. We are saying it
তাহলে
first
লেফট
finger.
হ্যান্ড রুল হবে না, এটাতে রাইট হ্যান্ডই হবে না?
Yes, right hand rule. Of course, right hand rule, because we are getting here induced EMF or current from kinetic energy, from the motion of the coil. Okay. So someone is rotating this coil from that side, and because of this, we are getting the current or EMF. Now, if someone is rotating it this way, that means clockwise direction. That means we are taking first CB. We are taking first CB. So if you are taking CB, it is going downwards, right? Isn't it?
Yes.
So your thumb should be now downwards. Make your thumb downwards. You keep your index finger to the right and make your thumb downwards. Then you will see the current is going towards you, right?
Yes, sir. এবার সরাইলাম, হাত যাইতেছে ব্যথায়।
Yeah. So your current is going towards you. That means you will get a current in this direction. So here, this end, you see here electric load, right? Electric load. So if the current is going in this direction, that means here you are getting positive. The way I'm labeling, you should also label. Otherwise, it will not be clear to you. I labeled here magnetic field. I labeled here that CB is going down, and I showed here positive, negative beside the electric load. Okay. You know that conventional current flow from positive to negative. So as the arrow is coming here, we are getting the current direction this way. That's why our positive will be this side and negative will be that side. Okay, now we are thinking about now AD, part AD.
স্যার
Yes,
আগে
tell me.
প্রথমে সিবিতে ওই তো নিচে যাচ্ছে, ওটা কি?
That means the coil,
সিবিতে
you
নিচে
see,
যাচ্ছে।
listen, I told you that there is rotation written here, right? Clockwise.
Yeah.
So generator means someone is rotating the coil, and because of this rotation, okay, because of this rotation of coil, we are getting the electricity, right? Is it clear?
Yes.
So from
Yeah.
kinetic energy to electrical energy we are getting. Is it clear now?
Yes, sir.
That's why it is generator. That's why it is Fleming's right hand rule. Now the arrow is downward, means this part of the coil is going downwards, right? Do you agree?
Yeah.
Okay, very good. Now in the same time you see AD, it is going upwards, right? Isn't it?
Yes, sir.
Yes. So if it is going upwards, then the current direction you are getting, you see, it's matching with this, right? The direction we already gave, positive to negative. The current direction is going in that direction. And if you are also applying the Fleming's right hand rule, that time also you'll get it is going this way towards the screen. Is it clear now? Are you done with all the labelings?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, now I will tell you about slip rings. What is the function of slip rings here? Look, this part CB, part CB is here, right? And when this one is rotating, the coil is rotating. In our previous one, can you remember the motor one? You must have the notes with you, and you can see in split ring commutator we had that the commutator changed the side, right? But
Yes.
here it is connected in a way. Look here, the slip ring is connected in a way. The part of coil is changing the side, but the connection is still same, isn't it? The ring it is connected, or the brass it is connected with, whenever it is going to the other side, like CB is rotating and it is coming to this place, that time also it is connected to the same brass and same ring. Is it clear to you? If you understand it, then we can go forward.
Yes, sir.
And this is the reason why we are getting here alternating current, because you will now understand why we are getting alternating current. That's why actually we needed another diagram, but I will show you in the same diagram. Now for this rotation, can I rub all this? Can I rub all this? Hello? Are you done
Yes,
with
sir.
all drawing?
Yes, sir.
Okay. Now look here, when this part CB will go there. CB is coming here and AD is coming into this place. What is happening? In this diagram you see. So if AD is going to here and CB is coming to this place, then we are still, it is connected to the same place, isn't it? Hello?
Yes,
Yes, sir.
sir.
Look here, it is connected here and AD is still connected to the part B. Okay, look, see here, this not part B, I am saying that the brass in the left side. So what is happening now? Check. Your magnetic field in the same direction, right? Isn't it? Magnetic field is in the
Yes,
same
sir.
direction. Do you agree? If you
Yes,
don't
sir.
agree, then tell me. So we are drawing here the magnetic field in the same direction. Now AD is going down. You do not need to draw it, just you understand it from here. Now AD is going downwards. Then what will happen? The current is coming in this direction, isn't it? Hello? Look, in which direction current is going? AD is connected
Downward.
to this slip ring, right? So current will
Yes.
go to this direction. You
B.
understand it clearly. Otherwise, it will be confusing for you. Look, the way of current conduction. I told you that the slip rings is still connected with AD in the same side. So the current will go now in this direction. Here. in this direction, current will go. Okay, if current is going this direction, then it will come here this direction, and this way it will go. Okay, for this
Yes, sir.
one, part BC, it is going upwards. The current is maintaining this direction, the direction shown here, right? So where you'll get positive and where you'll get negative now? Can you say
The
where?
positive will be
Sir,
the
এবার
positive.
চেঞ্জ হয়ে যাবে না?
Positive will be here.
নেগেটিভ নিচে।
Yes,
Yes,
negative will be downward.
in your diagram you drew already. You do it now. You give here positive and give here negative. Okay, and write the notes. The notes will help you now understand the whole thing. I will try to make the notes easier for
কোথা
you.
থেকে কোথায় লিখবো?
You do not need to write from the book. I will write. Whatever I am writing, you write
Yes, sir.
that part only. Okay? Because there are lots of discussions here. You do not need to write everything. Just I am writing here, you write that one. Okay?
স্যার কোন একটা হোয়াইট জায়গায় লিখেন স্যার, না হলে মিসড আপ হয়ে যাবে।
আচ্ছা না স্যার, টাইপ করুক, খালি পরে সাইডে না ক্লিক করলেই তো হইছে।
Yes, yes.
কারণ আমাদের বইটা তো লাগতেছেও না, সাদা
Adnan
জায়গায় লেখা থাকলো সব।
Adnan is very talented guy, mashallah. He is from Jeddah, you know. Then look here. We have from the beginning. I am saying, when we had there, look in the diagram. From where we started, there we'll go. Okay. When part CB of the coil moves down, we get current direction here you got electrical load, so you label that will help you to understand it more. You label here with X, Y, right here. This one you write X, and this one you write Y. Okay. Again, the format changed. When part CB, I'm writing again because it's not coming. Okay.
আচ্ছা স্যার, আপনি মুখে বলে যান, আমি টাইপ করি তাইলে। আচ্ছা, আসছেই তো।
When I'm writing, no problem. When part, I'm writing again, no problem. When part CB of the
স্যার ওইটা আর লেখা দরকার নাই, এখন নতুনটাই লিখি, বোঝা যায় কোনো মতে।
moves down, we get current direction And of course, it is conventional current direction. Okay, current direction from X to Y. From X to Y.
Sir, positive or negative to bola jay na?
Yeah, you can say positive to negative, but positive to negative is happening both the times, isn't it?
না প্রথমটার মধ্যে তো নেগেটিভ টু পজিটিভ
Positive to negative always.
Always it is the current direction is positive to negative. The current is, that's why I brought, otherwise it was easy also for me, right? When part CB of the coil moves down, we get current direction from X to Y. Again, when
Sir, do we need to draw these things like motor, AC motor, DC motor in the question paper?
no, you do not need
We
to.
just need to label it, right?
Yes, label it and give the answers according to the diagram. Okay,
Okay, sir.
is it clear? Again,
Yes, sir.
when the coil completes rotates one turn and then part CB moves. I am only bringing only one parts idea, then you can relate with other part, right? If I bring all the things together, then it will be clumsy for you, it will be a mess. So you understand by only one part, the other part is opposite of it. Is it clear? When
Yes, sir. Class time of prices.
yes, when the coil completes rotation one turn and then part CB moves upwards, then the current direction is from Y to X, right? Is it clear to now,
Yes, sir.
Aisha? So we are done.
Yes, sir.
We are done
Class
with
of yes, sir.
the most of the discussions. Now,
Yes, sir.
Last.
Okay.
at last, I will not write anymore. Just I will tell you about the slip rings. Here you already understood. I already explained the function of slip rings. So can you please summarize me, Yakin or Ziba or anyone? Can you summarize me about slip rings function? Can you summarize, please? Just 30 seconds. By 30 seconds, you will explain it. I think from our overall discussion, you understood it. Hello.
Sir, slip rings function is to keep the circuit connected, and
Yes, you slip rings help us to have the part CB or AD connected
For rotation.
in the same place, right? And
yes, in the same place,
by this what we are getting? By this we are
produces
getting the alternating current, right?
alternating current. Yes.
Yeah. We are rotating the coil in one direction, but we are getting the production of the induced EMF that is alternating. Is it clear?
Yes, sir.
Okay, if you want, then in our next class I will write it. Now we are over. Allah Hafiz.
Okay, sir. Rashi, sir.
Allah
Assalamu
Hafiz, sir.
alaikum.
Assalamu alaikum.
Alaikum assalam.